Hello everybody, I'm at school without my nice microphone, so I apologize. Video number 1 is going to be about sequences. A sequence is just a list of things, so it has an ordering to it. And in our class, we're only going to be looking at sequences of numbers, but later on in math, you could look at sequences of functions, for example. So an example of a sequence might be 2, 4, 6, 8, and so on. So you can see it's a list. Usually, so each number in the list is called a term, and the terms usually start with 1, and we usually denote them this way. So you have a variable and then a subscript that tells you which term in the sequence you have. So the first number is always the first term, the second number is always the second term, the third subscript denotes the third term, and so on. So if you wanted to describe the nth term, you would describe it with a sub n. Usually often instead of writing out the entire sequence, it would be shorter to just write the equation that tells you what the nth term in the sequence is. So here, the nth term equals 2 times n. So you can see if the subscript is 1, the first term is 2 times 1. Here I have a subscript of 2. This is 2 times 2. This is 2 times 3, and so on. So a shorthand way of writing this entire sequence is having this curly brace and then writing the equation that gives you the nth term. So it's actually wrong of me to write ... here. This is the same thing as the sequence 2, 4, 6, and so on, like that. Okay, so let's look at some examples. This is just to kind of practice the notation. So let's say that I have a sequence whose nth term is defined by 4 to the n over 3 to the n plus 1. Just to make sure you understand, try right now to write the first 5 terms in this sequence. Pause the video. Give it a quick think. Okay, so the first 5 terms in this sequence, I'll start by plugging in n equals 1. So this is 4 to the 1. Divided by 3 to the 1 plus 1 is 3 to the 2. So this is 4 over 3 squared is a sub 1. The next term would be a sub 2 would be 4 squared divided by 3 to the third, 4 cubed, 3 to the fourth, 4 to the fourth, 3 to the fifth, 4 to the fifth, 3 to the sixth. And so on. So these would be the first 5 terms right there. Okay, let's try one more just to make sure you've got it. And this will also illustrate a very common pattern you'll see. So let's say I've got negative 1 to the power of n over e to the n. Go ahead, give it a think. What are the first 5 terms? All right, so here, when n is 1, here I've got a negative 1 to the power of 1. So that's just negative. So I could write it this way, negative 1 over e to the first power. For the second term, I'll have negative 1 squared, so that becomes positive 1. And then this is e squared. When n is 3, negative 1 to the third power is again negative. So now I've got negative 1 e cubed. And then when n is 4 to the fourth power, this once again becomes positive. So you can see this negative 1 to the n power is creating this alternation of negative and positive signs for each subsequent term. And that's something that you see a lot, or it's not uncommon to see this with sequences. Let's do actually one more. So what if you have sine n pi over 2. Yeah, let's just do that. That's fine. Okay, give this one a little think. All right, when n is 1, I've got sine of just pi over 2. When n is 2, I've got sine of 2 pi over 2, which is pi. When n is 3, I've got sine of 3 pi over 2. When sine is 4, I've got 4 pi over 2, which is the same thing as 2 pi. And so on. But you know what these numbers are, and so it obscures what this sequence actually is if you leave them unevaluated like this. So you know that on the unit circle, pi over 2 is 90 degrees, and so sine of 90 degrees is 1. And then 180 degrees is over here, and sine of 180 degrees is 0. 3 pi over 2 radians is down here. That's 270 degrees, so that would be -1, and then back to 0, and so on. So this sequence could be most simply written this way. All right, so you already know that you can use this notation to describe the nth term in the sequence if you have an equation that describes the nth term directly. It's not uncommon to have a pattern where you don't know exactly how to define the nth term, but instead you define it in terms of the previous values in the sequence. So a very famous example of this would be 3, 5, 8, and so on. What would the nth term in the sequence be? It's kind of a tricky problem to figure out an explicit formula that would tell you what is the nth term here. But you know there's this relationship. The nth term is the sum of the previous two terms. So this is called a recursive relationship, or a recursive sequence, where a term is defined in terms of other values in the sequence. And one way you can notate it would be like this. You could say the nth term equals the sum of the previous two terms, except then you also have to say where does the sequence start. So you have to give a couple of values at the start. So the first term is 1, and the second term is 1. So now these three together would define this sequence. If I was going to change one of them, like let's make this one 3, now this would define a new sequence that still has this same pattern, where A1, the first term is 1, the second term is 3, this is for n larger than 2. So now that n is 3, I'll find the third term as the sum of the previous two. So that would be 4, that would be 7, and so on. Okay, so those are called recursive sequences, or a recursive relationship. Let's see. So as a test, let's just do a quick test of your understanding. So let's say the first term is 2, and let's say the nth term is just going to be 3 times the previous term like this. So go ahead and write the first 5 terms in this sequence, and then see if you know, see if you recognize what kind of sequence this is. So here the first term is 2. The second term, let's actually write for n larger than 1. So the second term would be 3 times the first term. So that would be, 6. And then I'd again multiply it by 3. And so on. So hopefully you recognize this. Well, maybe not hopefully. Let's put it this way. If you don't recognize this, come back like 2 videos from now, and you definitely will.